This is question 24 from the UKMT Senior Math Challenge from 2023. It says that a square has its vertices on the edge of a regular hexagon. Two of the edges of the square are parallel to two edges of the hexagon. So these sides are parallel, or these edges are parallel. As shown in the diagram, the sides of the hexagon have length 1. What is the length of the sides of the square? So let's start by splitting the hexagon up into some more manageable pieces. We'll go down the middle on either side. We know that the length of this is 1, so this will be a half. We'll call half the side length of the cube x, so that is x, and this is also x. And we know that this is 1. So we've got two right angle triangles, and of course this is a hexagon, so this angle here will be 60 degrees, and this will be 30 degrees, because the internal angles within a regular hexagon are 120 degrees, so we just divide it by 2. And over here we'll get 30 degrees because that's 90 minus 120 minus 90, and here we'll get 60 degrees, and it's another right angle triangle. We'll call this length the base of this small right angle triangle. We'll just write it as L, and we'll call the length of the larger triangle's hypotenuse M, and the smaller triangle's hypotenuse Z. So we know that M plus Z equals to 1. Let's use some basic trigonometry now to find out some equations in terms of x, so we can use simultaneous equations to solve for x. So let's draw out one right angle triangle first with M. We've got mx 60 degrees and 30 degrees. From this we can work out that cos 30 equals adjacent, which is x, over the hypotenuse, which is m. Remember, cos 30 is root 3 over 2. That equals x over m, and we can just write that as root 3 over 2 m equals x. So we've got one equation for x. Now let's look at the other smaller right angle triangle. We've got our length z, we've got L, and that's unknown. We have 60 degrees over here, 30 and 90. So we can do sine 30 equals opposite L over hypotenuse Z. Sine 30 equals a half, so that is a half equals L over Z. Therefore half Z equals L. If we look back at the hexagon, we'll look at this section over here. We can find out x in terms of L and this half. So if we add half and L, we get x. Let me write that here. Half plus L equals x. We can substitute that. We can substitute this half z equals L into this equation, and we'll get half plus half z equals x. So now we have three equations we can use. We have the m plus z equals 1. We have our root 3 over 2 m equals x, and we have our half plus half z equals x. We can forget about this equation because we've already substituted it in. We can equate this equation and this equation together, so that will remove the x. So that's half plus half z equals root 3 over 2 m. We can multiply through by 2 to get rid of the halves. So that will be 1 plus z equals root 3m. And now we can write that further as root 3m minus z equals 1. And that is one simultaneous equation. And the other one we have is this one, the m plus z equals 1. I'm going to move to this side here to get a bit more space. So we have our two simultaneous equations, one being root 3m minus z equals 1, and the other being m plus z equals 1. Because we have the minus z and the plus z, we can just add these two simultaneous equations together, and that will cancel the z. So we'll get root 3m plus m equals 2. Let's factorize out the m, so that's m root 3 plus 1 equals 2. So m equals 2 over root 3 plus 1, because we'll just divide 3 by m. Now we want to find x, of course, because x is half of the side length of the square. So let's look back at this equation over here. Root 3 over 2 m equals x. We'll just put a 3 over there, and we'll substitute our value for m into that to find the value of x. So if we do root 3 over 2 lots of 2 over root 3 plus 1, we get x, and that we can just cancel these 2's out because they multiply by each other, and one's dividing and one's multiplying. So that'll be root 3 over root 3 plus 1 equals x. Let's rationalize the denominator of this now. So we'll multiply the top and the bottom by root 3 minus 1. From that we'll get root 3 minus 1 over root 3 minus 1 root 3 plus 1, which will equal 3 minus root 3, and the denominator, that'll be root 3 times 3, which is 3, and these two cancel out and we'll get minus 1, so that's 3 minus 1, which is 2, so that equals x. But we know that the side length of the square is actually 2 lots of x, because we need 2 lots of those to make one side length. So we'll multiply it by 2, so just right here, 2x equals square side. So multiply that by 2, we get x, we get 2x equals 3 minus root 3, and that is the side length of the square. And yeah, we would get answer B in this instance, which is completely right. I've zoomed up if you want to get a better look at the working. Thank you for watching. I hope you found the video useful.